Okay, so today this video is about arithmetic sequences, but it's the recursive formula. So recursion is a process of choosing a starting item and repeatedly applying the same process to each term to arrive at the following term. Recursion requires that you know the value of the term immediately before the term you're trying to find. Okay, so the next part is knowing the formula. It has three parts just like before. So we still need A1, A sub 1, which is the starting value. And this time, A with a little n minus 1, that's the previous term. And then the letter D, just like yesterday's, was the common difference. Basically, the pattern. Okay, the formula, again, you do not have to memorize it, is going to be A sub n equals A to the n minus 1 plus your difference. And you also have to have A1 equals whatever number it is. So the only thing that changes are the A1 value and the D value. So the only thing that changes are the A1 and D value. So that's this one and this one. The A to the n minus 1 is just A to the n minus 1. Okay, so let's try this. It says write the first 4 terms of the sequence. So I'm given A is -1. So right here, that's my first term. So I already know the first is -4. And then it gives me the equation is A sub n minus 1 plus 5. This plus 5 right here is my pattern. I'm adding 5 each time. So first term, -4. Second one, I add 5, 1. Add another 5, 6. Add another 5, 11. Go ahead and pause this video and see if you can do number 2. Okay, number 2, you start with 6. The pattern right here is to subtract 2 every time. So 6 minus 2 is 4. 4 minus 2 is 2. 2 minus 2 is 0. Go ahead and do number 3 as well. Okay, so I'm starting at 2 and I'm adding 1 each time. So 3, 4, 5. So that was me given the first term and given the equation, which is the pattern, the formula. Now I am given the list of numbers and I have to figure out the formula. Okay, so just like in our other formula, explicit or recursive, there's 2 things I need. I need to figure out what the A1 is, and I need my common difference. So my A1 in this case is my first term, so it's 2. The common difference, the letter D, which is the pattern, is adding 2 every time here. Adding 2. And I'm using this formula right there. So it says A sub n equals A sub n minus 1 plus D, so plus 2, because we already found that, And you also have to identify a sub 1 is 2. You have to have this part. All of this is your formula. If you leave off a sub 1 equals 2, you're not done. Okay, so you guys write the formula for number 5. Okay, so I have a sub n equals a sub n minus 1. And then I put my pattern on it. So to go from 6 to 3, I'm subtracting 3. So minus 3. And there's my formula, but I need my starting. A sub 1 equals 6. So all of this is your answer. Okay, I'm going to skip number 6. Number 7 says identify the domain and range for each sequence. So your domain is always going to be your term numbers. So like what slot they're in. So 1, 2, 3, 4, 5. Okay, so my domain for this specific sequence is 1, 2, 3, 4, 5. Because there are 5 numbers. And then it has the comma, dot, dot, dot. Your range is the actual sequence numbers. 1, 6, 11, 16, and 21, dot, dot, dot. For number 8, it's a little different. They didn't give you the actual list of numbers. You have to plug it and see. So again, domain is the term number we're on. So 1, 2, 3. We'll just say there's 4 we're going to use. It doesn't specify. So my range is me actually plugging in these numbers. Okay, plug 1 in. 2 times 1 is 2. 2 minus 8 is negative 6. Okay, move to the next one. 2 times 2 is 4. 4 minus 8 is negative 4. 3 times 2 is 6. 6 minus 8 is negative 2. We're on the fourth one. 4 times 2 is 8. 8 minus 8 is 0. And then dot, dot, dot. Notice how since there's 4 numbers in the domain, there's 4 numbers in the range. They have to be the same amount. Okay, next we have these 2 graphs, and they're just dots. So if you can think back from forever ago, if they're dots on a graph and they're not connected, they're called discrete. So hopefully that rings a bell a little bit. We are going to do the domain and range with the graph. So for my domain, remember, domain are your x values. So I use 1, 2, 3, 4, 5, 6, and 7. Oh, hang on, not 7. I don't think I can count. 6. Sorry, we don't use 7. So 1, 2, 3, 4, 5, 6, and 7 are all of your domain. And they're not connected, so I'm not going to assume they're going to go on. Okay, well, those were my, oh, why did I put 7 again? 6. Sorry, guys, it goes through 6. Those are my domain. The range are the numbers that go with it. So my range is, let's see, that's going to be a 1, then 4, then 7, then 10, then 13, and 16. So I have 6 on my domain and 1, 2, 3, 4, 5, 6 on my range. So I know I've done it correctly. Okay, you have to have the same number on both. Okay, so you know how we skipped number 6? We're going to go back to number 6. Okay, on number 6, again, we're writing the recursive formula. So you need the pattern and your A1. Okay, so you always have A sub n equals A sub n minus 1. That's always the same. And then you put your pattern at the end. So let's see, my pattern to go from 32 to 22 is minus 10. 22 minus 10 is 12. Yep, 12 minus 10 is 2. So my pattern is minus 10, so I'm going to put a big minus 10 at the end. But you're not done, because you always have to say what your A sub 1 is as well. So A sub 1 equals 32. So for all of these, if I wanted you to find the 20th term, you literally have to know the 19th. If I want you to find the 100th term, you have to know the 99th, which means you have to know the 98th and the 97th and the 96th and the 95th and 94th and 93rd and so on. You have to know every single one in order to find this. Why do they make you know this? And why do they have a formula where you have to know the one before it? I'm not sure, because we learned explicit yesterday and that one's nice. If I need the 100th term, I just plug in 100. This one though, I have to know the 99th. And yes, you have to know both ways. But no, I will not make you find the 100th term on this and not give you anywhere close to term 100.